Okay, hello everybody, how's it going? We're gonna do the official video notes for Use the Binomial Theorem. I tried to give you a quick recap the other day, but let's see how we can do this. The binomial theorem is when you have a binomial, something with two terms raised to a certain power. And we talked yesterday about three different pieces. Notice that there's like this first coefficient part, and then we use A, basically the first term of the binomial, and then we use B, the second term of the binomial. And notice that those are present in every single term of the binomial. And what we do is we use the binomial theorem for binomial expansion, where we're going to write this out instead of in factored form, like as one long polynomial. So here's how we do that. Step one is that we're going to write the coefficients of each term using the nth row of Pascal's triangle. I'm going to do that in pink. Step two is that we're going to, from top to bottom, include the first term of the binomial with each term of the expansion using exponents in decreasing order. Then we include the second term of the binomial in increasing order. I'm going to color code step 2 in green and step 3 in blue. Okay. So then what we do is we just basically simplify those and then we add them together, except if it's a minus sign, then we're going to alternate. So first we'll need for our lesson the Pascal's triangle up through row 6. We talked about how fun Pascal's triangle was. Row 0 just starts with 1. Then we work out. There's row 1. Row 2. Again, 1's on the bookends, and then we add to get the numbers in the middle. Row 3. Row 4. Row 5. And row 6. So now we should have enough rows in the triangle to perform all the problems that we want to look at today. Okay? So this says to use the binomial theorem to write the binomial expansion of x, the quantity x plus 4 to the 5th power. So because it's to the 5th power, that means that we're going to use the 5th row of Pascal's triangle. We look at the 5th row, the one that has 5, or if you're counting 0, 1, 2, 3, 4, 5, and we see that we have 6 entries. And what that means is that we will need 1, 2, 3, 4, 5, 6 different entries. Oh, 6 different entries here. Okay. Then step 1 is to write the coefficients. So we would write 1, 5, 10, 10, 5, 1. That's step 1. Step 2, we start with the first term, which is x, and we start by raising it to the 5th power. Then in the next term, we go 1 lower, x to the 4th, then x to the 3rd, then x squared, then x to the 1st, then x to the 0. And I'm just going to write the x to the 0. I know it's 1, just to be consistent for today, okay? Now we take the second term of the binomial, 4, and we go the other way. We'll start by raising it to the 0 power, and then we'll increase the exponent each time. So 4 to the 1st, 4 to the 2nd, 4 to the 3rd, 4 to the 4th, 4 to the 5th. Because it's addition, we know that each term will be positive. Okay. So after you do that, the next thing we want to do is get rid of parentheses. That's our next thing, is just to rewrite everything without the parentheses. So if we did that in this first term, we would have 1 times x to the 5th times 1. If we did that in our second term, we would have 5 times x to the 4th times 4. In the third term, 10 times x to the 3rd times 16. And we would continue doing that. Notice getting rid of the parentheses, evaluating anything that's in the parentheses. And I'm just putting little multiplication symbols between them. For us to remember that everything that we multiply is going to stick together. And we will still have 1, 2, 3, 4, 5, 6 terms in our final answer. Okay. Finally, let's make each of these terms as simple as possible. 1 times x to the 5th times 1 can just be written as x to the 5th. 5 times x to the 4th times 4 can just be written as 20 x to the 4th. This can be rewritten as 160 x cubed if we multiply. The next term, when we multiply these factors together, 640 x squared. The next term, obviously you can use your calculator. 5 times 256 is 1,280. And then our last term. And notice we have 1, 2, 3, 4, 5, 6 terms. And notice that when we happy cloud our final answer, that this is a polynomial, right? And that's our goal in binomial expansion, okay? Notice we want to make sure that we use parentheses. In this one, it wasn't too big of an issue. And then in our answer, we got rid of parentheses, and we double-checked our signs. In addition, these are all positive. Okay, let's try another one. Let's do number 2. And this is the quantity 2m minus n to the 4th. So in that case, what we'll do is we'll use the 4th row of Pascal's triangle. If we look at the 4th row has 1, 2, 3, 4, 5 different entries in it. So in the 4th row, if we look, we'll have our first part. The entries are going to be the coefficients to start. 1, 4, 6, 4, 1. Then again, we'll start with this first term, 2m. In parentheses, we're going to raise it to the 4th power and work our way down. Now we have 2m to the 3rd power, 2m to the 2nd power, 2m to the 1st power, 2m to the 0 power. Just ignore the sign for right now and deal with the second term, which is n. We start with n to the 0. Then we do n to the 1st, n to the 2nd, n to the 3rd, n to the 4th. Notice that this time we have a negative. It's this negative that tells us that we want to alternate signs. So the first one will be positive. Then we'll have a negative, a positive, a negative, a positive, and then we're all set. So that's a beautiful setup. Now we need to get rid of the parentheses. So I have 1, but let's be careful when I have 2m to the 4th. Don't I raise both the 2 and the m to the 4th power? So 2 to the 4th is 16, and m to the 4th is m to the 4th. So 2m to the 4th gave me 16m to the 4th. And then times 1, because anything to the 0 is 1. My next term, I have the 4. Now 2m cubed I would have to cube 2 and n. So I get 8n cubed. And then that's n to the first, or just n. My next term has 6. If I square 2m, I get 4m squared. And I also have this n squared. In the next term, I have the coefficient 4. 2m to the first is just 2m. And then I have n cubed. And then here I have 1 times 1 times n to the 4th. So we've gotten rid of the parentheses and applied the exponent to everything we need to. So we got rid of parentheses when we used them. Okay. So now what we need to do is write our final answer. Just simplify each term. That could give me 16m to the 4th. 32m cubed n, 24 m squared, 8 mn cubed, and then n to the 4th. And then there's a polynomial with 1, 2, 3, 4, 5 terms. Okay? 2 more. Oh, and then my signs, you guys, sorry, because I alternated signs, again, notice positive, negative, positive, negative, positive. Okay, so we checked our signs. So let's look at example 3. Let's try this one. We have 5x minus 2y cubed. So we'll use the third row of Pascal's triangle. The third row, if we look, has 1, 2, 3, 4 entries. Those coefficients will be 1, 3, 3, and 1. So let's try to put that in there. We'll start with 5x. We start by raising it to the third power. And then we work our way down. And no, you don't have to write the things to the 0 power. I just think it helps kind of flesh it out a little bit and make sure we're not skipping any steps. Now we're going to look at the 2y and then raise it to the 0. And then we want to increase the exponent each time for this guy. So 2y to the 0, to the first, to the second, to the third. Let's check out our signs. We have this minus, which means we need to alternate the signs. So we have positive, negative, positive, negative. Okay? Remember, next we get rid of the parentheses. We evaluate all of these different things. So yes, we used them. So now let's get rid of the parentheses. 1. 5x cubed would be like 125x cubed. 2y cubed is just like 1. Sorry, 2y to the 0 is just like 1. Next term, I have 3. 5x squared is like 25x squared. 2y to the first is just like 2y. Next term, I've got 3. 5x to the first is 5x. 2y squared is 4y squared. And we move on to the next term. 1. 5x to the 0 is 1. And 2y cubed is 8 times y cubed. Now let's simplify each term. 125x cubed. Here I can multiply 3 and 25 and 2 together to get 150. And then I had x squared y. Here I can multiply 3 and 5 and 4 together to get 60. And then I have xy squared. And then here this is just 8y cubed. Oops. And there's the final answer. We got rid of parentheses in step 2. And look at our signs. They alternate. We're good to go. Right? You guys, instead of doing this example 4, I'm going to do the U try C on the over here, just because these have exponents in them, and I want to talk to you about what that would be. Okay? So because it's 4, what we do is we use the 4th row, which has 5 entries. 1, 2, 3, 4, 5. My coefficient of row 4 are 1, 4, 6, 4, 1. Then I'll take 4x cubed and raise it to the 4th power. Again, that whole 4x cubed raised to the 3rd power, and so on, all the way down to get to the 0 power. Now I take the second term, y squared, and I start raising it to the 0 power. And then I work my way up each time. It would help if these were sharpened, sorry. Then for signs, if it's positive, I just put addition. But notice it's negative, so I need to alternate. Now let's get rid of the parentheses. I have 1. And when I have 4x cubed to the 4th, I have to raise 4 to the 4th power, which is 256. But I also want to take x cubed to the 4th power. Do y'all remember what we do to these exponents? Remember, we multiply them together to get x to the 12th. And then y squared to the 0 is just 1. Let's do the same thing for the next term. I have 4. Now I have 4x cubed, which means I need to cube the 4. And then cube x cubed, so I multiply those exponents together. Y squared to the first is just y squared. This is a 9, I don't know if you can see that. Okay. The next term, I have 6. 4x cubed squared means I square the 4 and square the x cubed to get 16x to the 6th. Y squared squared, again, I'll apply the exponent by multiplying y to the 4th. I have 4. This was supposed to be 4x cubed to the first, which is just 4x cubed. Y squared to the 3rd is just y to the 6th. Last term, I have 1. 4x cubed to the 0 is 1. And y squared to the 4th is y to the 8th. Now I just combine the factors into one beautiful term. Multiply all the numerical values together in each of those terms. And traditionally, the variables are kept like in alphabetical order. So the x's usually come first, but it doesn't really make a difference, to be honest, okay? And you don't have to underline each term in your answer. It's just I've seen a lot of weird things in my years, and I want you to understand that when we had 5 different pieces to begin with, our final answer should have only 5 different pieces. Like, these are the only symbols that I should see are the ones between each term. I know this is tedious, but these steps are really helpful, I think, in ensuring that you get a polynomial that's correct at the end. If you guys want the answers to the U-try or to this one, you can just go on your ePark 2, but hopefully that talks you through the binomial theorem. Again, I know these steps are tedious. They're not hard. You just got to think through it and do the process. So please do that. Okay, I'm going to stop talking. You guys can start your homework. It's the rest of that worksheet. We'll talk to you soon. Okay, have a good day. Bye.